Welcome to web series 3 of Miss Universe Prediction. So, a lot has happened since you guys were last here. Let's go and see what my team is up to.
Okay, Shri, so a few weeks ago we were really worried about the data, and I think now we have a reasonable amount of it, and let's see whether we can proceed with the machine learning analysis. Yeah.
So let's first summarize what all data we have,
Yeah, sure.
and we'll try to identify what all we need more.
Correct.
Like for summarizing the data that we have, we'll split the data into two parts. That is, we have data with respect to countries, and we have the data of contestants. So let's see what data we have for a country. Like we have the list of all countries that are competed for Miss Universe title, and for each of the countries, like this is the country name that we have, country name, and you have the number of times the country has won the title, number of times they were in the first runner-up, number of times they were in the second runner-up, and so on, number of times they were in the fourth runner-up, and number of times they came up in the semi-finals, and number of attempts the country has made. So this is the data we have for countries. This we have for 86 of the countries that has competed in Miss Universe until date from 1952. So apart from rather than just focusing on Miss Universe, we have the data for other three beauty pageants. Out of the big four, we have the country-wise performance data for the other beauty pageants. And apart from this, going to contestants, we have from 2011 onwards, 2011 to 13, we have the contestants' images and their beauty score rating. We have made use of two models that we already discussed. One is Lee House model and another one is Anna Face. We have made use of these two models to come up with a beauty score for contestants from 2011 to 13. We restricted because only from 2011 because we were able to get a front facial good images only for these contestants. This is one area where we need to work more. We need to try to collect data for other years also. And we have collected the data from 1952 to 2013, the list of all winners and their images also. So this is a good data set where we can rank beauty to some extent. And apart from that, from 2009 onwards, for each of the contestants, we have the age and height of the contestant. So this is quite a big data set where we have about 404 entries. Like we have the age and height of all the winners from 1952 to 2013, and we have for the contestants from 2009. So we have a mix of where we have a lot of winners and more number of losers also. So we make use of the winners and losers data to come up with the machine learning algorithm here. So this is the data that we have right now, and I think it's quite sufficient that we move forward with machine learning algorithms. And we'll try, one thing that we can try is we can try to get the age and height of the contestants from other years as well as from other beauty pageants. Because we quite think these beauty pageants have similar kind of grading criteria, so we can try that. And for countries, do you think we need anything else?
Yeah, Professor Ina suggested to us we should also include GDP and population of the country.
Yeah, so now we finalized what data we need to use for the machine learning algorithms. Let's look at the algorithms which we can actually use for this
I
data.
think our problem naturally falls into classification category.
Yeah,
Right.
we need to look at class. So we look at the classification algorithms that we are going to use for our machine learning model. Considering that our data set is quite small, we'll stick to those models that are found to be successful with less data. So one is we'll go for logistic regression, then we'll go for naive Bayes, and then another thing is you can try out linear SVM. So these are three models we are going to try out for the current data set that we have, and depending upon the results we'll fine tune the model and see how it comes.
So we actually need to apply these three algorithms on our data and calculate the accuracy. So this is our data set. We have the age, the height, and the country score for the contestants in the past. So we have 404 rows of this. So mainly we have losers, right, in our data set, because there have been very few winners since we have the Miss Universe is going on since only like around 63 years. So we have only 63 winners in our data set. So what we are planning to do is we are trying to shuffle the data set so that randomly there'll be randomly the data set will be divided into training and testing, and we plan to use this to actually calculate the accuracy of logistic, naive Bayes and linear SVM and see which turns out to be better for our model.
So we were using Anna Face to get a beauty score for all of our Miss Universe contestants. We thought, why limit it only to the contestants? Let us apply it on our faces and see how beautiful we are. So, our first target, Professor Steven Skinner. Let's see how it went.
First of all, let's go back now and take a look at this. You're trying to build a feature matrix of country data and how their performance is at beauty contests.
Yeah.
Now, the thing I'm worried about when you just sort of take a look at how many times a country has come in first or second or third is you have very small sample statistics.
Yeah.
And it seems like it's a very noisy thing. One win 1 year would cause a dramatic change in your statistics.
Yeah, like
What other things can you do to make that data richer?
we were like thinking like we have a similar kind of data metrics for all the contests like Miss Universe, Miss Earth, Miss International,
Right,
and Miss
right,
World.
right. Okay.
So we thought like we'll keep the other three as a training set, and we'll have this model where we predict ABCD values, and we'll have we'll plug these ABCD values for the other three models, and we'll come up with a score, and we'll use the same values for Miss Universe and see how the scores are related.
What are you trying to predict at the end? A probability of winning?
Yeah, like our data metrics, we are thinking like we'll have the country name and we'll have a list of parameters. Like one would be the country, like what is the probability for that country to win, and
Right.
the one would be the contestant details like age of the contestant, height of the contestants. So our data metrics, one of the parameters would be the probability of that country.
But be that there's, again, a couple of different things you want to do. One is, your data, as you said, is very sparse and it's very irregular.
Yeah.
Okay? So you don't have very much detail or resolution in this. Simply because there haven't been that many contests. There's only one winner. Every year you're getting information about very, very few countries. So you don't really have very much information total. Would it pay to learn more about what kind of countries do well in these kind of things? So the question of like, what is the effect of population seems to be a legitimate question here. Does it pay to try to see to what extent the number of wins, the population helps predict the number of wins? Does the education level predict the number of wins? The number of years that you have been competing in these contests, how many contestants you have? And it would seem to me that that would form a much more, a better resolution model. Part of me says if you want to produce some kind of a score about the likelihood of a country winning, it's probably got to factor not only the, the observed behavior that you have in terms of how they've performed, but what you know about the countries themselves. Okay, and you've got, I like it, the way I would think about it is maybe you want to take things like regression, the education level or the population of a country, okay, or the income level of a country. That may very well, these things correlated positively or negatively with their chances of winning. And based on this, now you should be able to produce a model that depends upon the properties that all countries have and see to what extent that predicts it. Okay?
Professor, I have one question here.
Yeah.
You mentioned that for every country we consider population and social status.
Yeah.
How can we come up with what weight to give to each
Well,
of
this is
these
why they
parameters?
invented regression.
Okay.
You know, you're saying you're going to, for example, do democracies do better than, there's forms of government. And I imagine certain forms of government are more or less conducive to,
Beauty contests.
and I imagine that there's certain religious groups, certain nations, and cultural things. I would imagine some nations don't participate as enthusiastically in these kind of contests as other ones do. And that probably affects, and so my claim is if you have a rich enough matrix of properties of countries, and you have a measurement of the success rate in beauty contests, okay, which again I agree, take them over all the contests you can figure out, properly weigh each performance, not just how many did they win and lose, but how close did they come to winning. And now you're going to try to predict beauty contest performance for each country, okay, and that then I claim is now a regression. And I can imagine your final score will be a weighted variables, the regression weighted properties of countries, and these scores. It might be interesting to see which countries do better on beauty contests than you would think they should by this kind of scoring system, which ones do worse. That would be actually interesting to see. But I'm kind of imagining that a function of both of these, the performance and these other national variables, okay, to try to predict that performance, both of them would have predictive value here.
Anyone
Could
can
you
upload
use
their
could you use
photograph.
Anaface to figure out what my beauty score is?
Yes, you could.
Are you better looking than me, or how are we going to figure this out?
Yes, we use that Anaface as one of the beauty score thing, and then we got the help of one of our PhD graduates, that is Lee Ho, and we were able to make use of his model to get the beauty score for us.
Lee Hao is a PhD student from Stony Brook University. He has developed a model which gives a beauty score of an image. So we wanted to see if we could use his model on our Miss Universe contestant images and see if we could get a beauty score for those.
It's very hard to tell. So it's a two-layer neural network basically, but the activation function is adaptive. So in a traditional conventional neural network, the activation function is something like a sigmoid, right? Or just a step function. Yeah, but in my model, it's adaptive. It's basically piecewise polynomial. So it could be everything. Okay, I will show you. So this is the distribution of the scores, by the way. This is the samples. We have the scores from 0 to 20. This is the distribution of dataset 1, dataset 2, the distribution status. Okay, let's go to my network model. So, okay, so this is a ground truth. This is by the way, yeah. What we can do is we can exchange dataset. So you can do some labeling on this dataset, and I can train on your dataset. And after that, we can mix dataset, and I can train a final model and give the model to you. So you will have a model which takes the input of an image of a face and output a score here, so that you can.
Well, last time we were really worried about the data. This time we have some substantial amount of data, and we are able to run few machine learning algorithms. The accuracy part of those, it's not quite good currently, but we will improve it by including some more features. So, while scraping the data from the net, we wanted to scrap one table from Wikipedia, and to avoid manual labor, we decided to write a Python script, and we took 3 hours to create the Python script, and it was still, we were not sure whether it was going to scrap the data correctly. So we just at the end abandoned that effort and manually put that data within some 15 to 20 minutes. I think we should be able to predict top 5 out of top 16 with good accuracy.
Okay.
Machine learning algorithms that Professor discussed in the class, they are quite helpful. we tried linear regression, logistic regression, and Navy base. So yeah, the class is quite helpful. So we have actually a lot of fun while doing this project, and we don't know the reason, but we laugh a lot when we are working on this project. And Srinath is always entertaining us with his pranks throughout the project.
We are having a lot of fun doing this project, and like we have all gelled together very well. We are in our first semester, and like the graduate school is quite hectic, and it is during the time that we do this Miss Universe project that we have a lot of fun. Like it is a stress buster for us when we are doing the other subjects. So we have gelled so well that even though we have done the project, we sit for the entire night, chit chat for the entire night, and then only we leave. Professor Skinner's class is it's very good that it gives a very makes your basics very strong. That is, you get a solid understanding of the basics, and this helps us a lot while applying those concepts in our project. And moreover, he discusses about the pitfalls that you tend to fall while doing this data analytics. So we have felt like whatever he says in the class, like we are almost all times we are almost there falling into the pitfall, but his suggestions and others helped us to identify that we are doing something wrong.
So how do you feel about the progress of our project?
Right now we feel that we are progressing well, we are in the right direction, that's what we feel. At first we were concerned that we have no other data other than these images of Miss Universe, so we are totally worried, we have not done much of image processing, so we are totally worried how to convert those images into knowledge. So for that, Professor Skin has helped us in contacting some other people, they are helping us out to rank these images, and apart from that we are able to get data from other sources also. So we have a baseline model and a current model that is kind of fine. We need to improve upon it by considering the beauty scores. That is what we are working on right now, and we feel like we are progressing in the right direction. Our model, even the baseline model and the current model, our prediction is Miss USA is going to win. And I kind of like her profile and stuff, but my personal choice would be Miss Philippines, that is Mary Jean Lastimosa. I feel I like her. I feel she would be the winner, but our model suggests Miss USA. We'll see, we'll try improving on the model such that Philippines may be also the Miss Universe. We'll see that. What are the most interesting things you have learned from the problem domain?
Yeah, so we were looking at the history of beauty pageants when we were giving the presentation and everything. So how Miss America started was they would actually have these women, they would measure their the vital characteristics and their forehead length and the distance between their eyes, and if these dimensions were proper, they would actually get promoted to the next level. So that's how beauty pageant started. That was something very interesting I came across during the evaluation of the history of this domain.
Experience to report?
Yeah, so we were actually working on logistic regression using our data as input. So we had actually two different scores for the countries, okay? And the one score was according to how the country has been performing in all the big four competitions, big four contests. And one score was given, there was a miscommunication amongst our group members. So one score was just given on the basis of whether the country actually won or came in semi-finals, etc. And because of this miscommunication, we were using the wrong scoring. And we got a 97% accuracy when we actually tested it on 2009 data. So which was very surprising, and then that's how we quickly realized that, okay, we're doing something wrong here. So it was pretty funny.